In that case, we can write glide reflection, so gamma is our glide reflection. Of course, we can write it as sigma m followed by reflection in some line q that we know is of the point m is of this line q. So that's all we know about this line q. M is of line q. If we manage to find such a line, then of course it must be unique by cancellation law. So what kind of line would that be? Let's just look how it acts on P. What does it do with P? So sigma q sigma m applied to P will take us first to Q, and then since gamma must take us eventually to Q, then we understand that Q small must be the line through QB. So we must have that if we start with the glide reflection taking P to Q, then it's of the form sigma m have turn around the midpoint followed by a reflection in some line through Q. On the other hand, if we take any arbitrary line through Q, if Q is arbitrary such that point Q is on it, then this of course will be a glide reflection. Except in which case? Except when M happens to be on this line. So if we consider this line PQ, so for any, on the other hand, for any line Q containing big Q except when Q is exactly PQ, except for this case, sigma Q sigma M of course will be a glide reflection because point M will be off line Q. Taken, easily checked, taking P to Q, plug P into M, you will get Q right away. Since Q is through the point, then it will leave it intact. So this will be a glide reflection taking P to Q. So the only case, the only exception is when we have line Q which is passing through M. So what will be the result in that case? In that case, we'll have sigma Q times sigma M, which can be written as sigma Q times sigma M. So in that case, we'll just have reflection in the perpendicular bisector, and we have this case covered. So all odd isometries thus will be exactly of this form for any line Q. When Q does not pass through M from the midpoint, we have a glide reflection. When it does pass through M, we have a reflection. So we can state that all odd isometries taken P to Q are sigma Q sigma M. While all even isometries, remember, were sigma Q sigma M. So to summarize, this is the solution to the problem. All possible isometries taking one given point P to another point Q are of either of these two sorts, where Q is arbitrary line through point Q, and M perpendicular bisector of PQ, M midpoint of PQ. So final challenge in this podcast for you is repeat the above problem without using lines through Q. So how would you do that? Maybe pause for a second if you don't want to hear a hint. If you do, the hint is, of course, use lines through P. Alright, I'll see you next week in class.